Right now, while you are sitting there, doing something ordinary, a machine older than most people watching this is moving through a place no human being will ever touch. It is farther than the planets, farther than the sunlight that once felt like home. It has almost no power left. It should have died years ago, and yet it still whispers. Not with words, not with a message, with a thin, eerie signal that came from the charged matter between the stars. Once you understand what that whisper really is, this mission stops feeling historic and starts feeling personal. This is the hidden story of Voyager 2. Welcome back to Proof, where we uncover the hidden truths of the cosmos. If you're new here, subscribe now, because what you're about to hear is one of those stories that feels impossible until you realize it is real. Voyager 2 did not begin as an immortal machine. It began as a plan with limits, a short mission, a practical mission. Go to Jupiter, go to Saturn, take the pictures, measure what you can, then fade away into the dark. That was the idea. Back in 1977, nobody seriously expected this spacecraft to still be alive nearly half a century later. The people who built it knew space was hard. Electronics fail, fuel runs out, power drops. Tiny problems become fatal when help is impossible. Spacecraft do not last because you believe in them. They last because every part survives one more day than anyone had a right to expect. Voyager 2 launched from Earth on August 20th, 1977. It left only a little before its twin, Voyager 1. The names make it sound backward, and in a way they are. Voyager 1 launched later, but it took the faster path and reached the outer frontier first. Voyager 2 took the longer road. That longer road is the reason this story is so strange, because the timing was perfect, or maybe unsettling is the better word. The outer planets had lined up in a way that almost never happens. About once every 176 years, Jupiter, Saturn, Uranus, and Neptune sit in positions that allow a spacecraft to steal a little gravity from each one and swing toward the next. This move is called a gravity assist. It means a spacecraft borrows motion from a planet instead of carrying all the fuel itself. That rare alignment gave NASA a chance that nobody alive at the time would see again, and Voyager 2 used it better than anything else ever has. It became the only spacecraft in history to visit all 4 outer giant planets in one journey. Think about that. Only one machine from Earth has ever flown past Jupiter, Saturn, Uranus, and Neptune up close. It is still out there. Before we go deeper, drop a comment and tell me where you're watching from. I always like seeing how many corners of Earth are connected by stories like this. Voyager 2 reached Jupiter in 1979, then Saturn in 1981. Those flybys alone would have made the mission historic. Jupiter was not a quiet world. It was violent, huge storms, intense radiation, moons that looked like separate worlds with separate histories. Saturn was just as shocking in a different way. Rings that looked delicate from Earth turned out to be structured, chaotic, and alive with motion. But that was supposed to be enough. It would have been enough for almost any mission. Then came the decision that changed everything. NASA did not stop. Instead of letting Voyager 2 end after Saturn, mission planners turned it toward Uranus and Neptune, 2 planets no spacecraft had ever visited. Even now, no spacecraft has returned. That means some of the most important things humanity knows about those worlds still come from one passing visitor that arrived in the 1980s and never came back. At Uranus in 1986, Voyager 2 found new moons and new rings. Uranus already had known moons before the flyby, but Voyager 2 revealed 11 previously unknown ones and also found 2 new rings. A planet that had looked calm and distant from Earth suddenly became more complicated, more crowded, less understood. Then came Neptune in 1989, and then everything changed again. Voyager 2 saw a storm tearing through Neptune's atmosphere so large it could swallow Earth. Scientists called it the Great Dark Spot. It also confirmed that Neptune had rings, faint, strange, real. The outer solar system was not empty decoration. It was active, violent, full of weather, motion, and unfinished stories. That Neptune flyby was the end of one mission, and the beginning of another. After that, the cameras went dark. There was nothing left ahead to photograph in the old way. No more planets rising in the frame, no more moon close-ups, no more blue giants waiting in the dark. Voyager 2 stopped being a planetary tourist and became something far stranger. It became an interstellar witness. There's something else attached to this spacecraft that matters more than most people realize. On its side sits a gold-plated record. Not because NASA expected it to be found, not because anyone could promise there was someone out there to hear it, but because somebody decided that if a machine from Earth was going to leave home forever, it should carry a trace of us. The record holds greetings in 55 languages. Sounds of surf, wind, thunder, birds, whales, and human life. Music from different cultures and eras, 115 encoded images, human anatomy, streets, shapes of life, patterns of science. Instructions are etched onto the cover to show how the record can be played. It is one of the most hopeful things humans have ever built, and maybe one of the loneliest, because the truth is brutal. It will almost certainly never be found. That record is not headed toward a waiting audience. It is drifting into an ocean so empty that collision is almost unthinkable. But the fact that it is there changes the way you hear the rest of this story. Voyager 2 is not just a machine gathering data. It is also a bottle thrown into a cosmic sea, carrying proof that Earth existed, that we looked up, and that we wanted to be known. Then came the real frontier. Most people imagine the solar system as a set of planets circling the sun, and that is true, but incomplete. The sun is not just a bright object in the middle. It throws out a stream of charged particles called the solar wind. Those particles and the sun's magnetic field create a huge bubble around our system. That bubble is called the heliosphere. Everything you normally think of as home lives inside it. Earth is inside it. Mars is inside it. Pluto is inside it. The comets that loop in from the cold are still inside it for part of their journey. The heliosphere is like a giant invisible shelter pushed into the surrounding galaxy by the outward breath of our star. And beyond it is something else, interstellar space. Not empty in the simple way people say, not full of air, not full of sound, but full of particles, magnetic fields, radiation, and plasma left behind by ancient stars. Plasma is a gas whose atoms have lost electrons, which means it carries electric charge. It behaves differently from the air around you. It responds to electric and magnetic forces. It can ripple and vibrate in ways that feel almost alive. For years, scientists were not sure how the edge of the heliosphere would behave. Maybe it would thin out slowly. Maybe it would fade into the galaxy over a huge distance. Maybe there would be no sharp line at all. That was the expectation. Then Voyager 1 got there first in 2012, and the story became much stranger. The crossing was not a slow fade. It was sharp, fast, a real boundary. Solar particles dropped. Cosmic rays from outside surged. The environment changed in a way that told scientists this was not just more of the same. It was a frontier, but there was still a problem. One spacecraft is evidence. 2 spacecraft are confirmation. What if Voyager 1 had crossed in a strange place? What if the sharp boundary was local? What if the result depended on one path, one angle, one moment in the sun's cycle? Science is full of discoveries that seem huge until a second measurement says otherwise. So the question stayed open. What would Voyager 2 find? 6 years later, on November 5th, 2018, Voyager 2 answered. It crossed the heliopause too. The heliopause is the boundary where the solar wind is no longer strong enough to push back the material beyond it. In simple words, it is where the sun's bubble stops being the boss. Voyager 2 reached that boundary more than 41 years after launch. And when it did, the instrument saw the same kind of sudden change that mattered more than almost any headline could explain. Because now the edge of our solar system was not just a one-time event seen by one machine. It was a real physical boundary measured by 2 spacecraft, approaching from different directions years apart. That is not a rumor. That is not an internet myth. That is one of the cleanest confirmations in all of space exploration. In 2019, 5 scientific papers were published together in Nature Astronomy based on Voyager 2's crossing. Different instruments, different measurements, one picture. The sun's protective bubble has an edge, and that edge is stranger, sharper, and more dynamic than many scientists expected. But that is not even the strangest part. Here's where the story starts to sound haunted. One of Voyager 2's key instruments is the plasma wave subsystem. It measures electric field vibrations in the plasma around the spacecraft. Let's slow that down. There is no normal sound in space. Sound, the kind your ears hear on Earth, needs matter like air or water to carry pressure waves. Deep space is far too empty for that. So when people say Voyager heard sound in interstellar space, that phrase needs care. What Voyager detected were plasma waves. These are vibrations in charged particles, not sound moving through air, more like an electrical trembling in the thin stuff between stars. Now here is the twist. Some of those frequencies happen to fall into the range human ears can hear if you convert the signal and play it through a speaker. The instrument does not make a spooky recording by itself. It measures the electric field over and over, turns that into data, sends the numbers to Earth as radio telemetry, and then scientists can translate the frequency and amplitude into audio. That matters. Because the sound is not fake, it is not added for drama, it is not somebody in a studio inventing fear. It is the real pattern of plasma vibrations, rendered into a form your ears can understand. When NASA released the sound connected with Voyager's plasma wave data, what people heard was a thin rising tone, not a voice, not a code, not a warning. A change in the density of plasma beyond the heliosphere. Lower tones inside the sun's domain, higher tones in interstellar space where the plasma is denser and colder than what Voyager had been moving through before. That jump was one of the clues. It told scientists the environment had changed in a measurable way. And Voyager 2 backed it up. The readings showed a large increase in electron density after crossing the heliopause, similar to what Voyager 1 had found. In other words, both spacecraft reached a place where the thin, charged matter around them became much denser than it had been inside the heliosphere. That is one reason the translated signal sounded different. So no, NASA did not decode a terrifying secret message from beyond the solar system. The truth is more honest, and somehow more unsettling. What you are hearing is the electrical texture of the space between stars pressing against a machine from Earth. Sit with that for a second. A human-made object left home in the 1970s, crossed the edge of the sun's influence, and is now sampling the charged matter of interstellar space itself. The hum is not fiction. It is the frontier made audible. Here is the part they did not explain in the clickbait version. Voyager 2 did not just confirm a boundary, it also helped reveal that the boundary is not simple. The plasma beyond the heliosphere looked warmer than some scientists expected. That suggests the region may be compressed or shaped unevenly. The heliosphere may not be a neat, perfect bubble. It may be pushed, squeezed, and distorted by the surrounding galaxy and by the motion of the sun through interstellar space. So even now, after decades of study, the edge of our cosmic home is still not fully understood. That should bother you a little, because it means the map is still unfinished. And the only machines making direct measurements out there are old, very old. Voyager 2 survives on a radioisotope thermoelectric generator. That long name means a device that turns heat from decaying plutonium into electricity. No sunlight required, no solar panels reaching toward a weak and distant sun. Just radioactive decay, slow and steady, producing less power every year. About 4 watts disappear each year. That may not sound like much, but out there 4 watts can decide whether a scientific instrument lives or dies. The engineers have been making sacrifices for decades. The cameras went off after the planetary mission ended. Other instruments followed. Some were no longer useful. Some cost too much power. Some failed. Some had to be chosen against in a brutal kind of triage. By 2024 and 2025, the cuts became even harder. Voyager 2's plasma science instrument was turned off in September 2024 to save power. Its low-energy charged particle instrument was shut down in March 2025. Voyager 1 lost instruments too. Teams on Earth were no longer extending a healthy mission. They were keeping an elder machine alive hour by hour, watt by watt. That would already be enough to make the story intense. But here's another twist. In 2026, NASA engineers found a workaround for Voyager 2. They called it the Big Bang. The name sounds dramatic, but the fix was practical. The team switched off some powered devices and replaced them with lower power alternatives while still keeping the spacecraft warm enough to operate. That freed up enough energy to keep Voyager 2's 3 remaining science instruments running at least about another year longer than expected. 3 instruments? That is what remains of a machine that once carried 10. And yet, those 3 still matter. The magnetometer measures magnetic fields. The plasma wave subsystem keeps listening to plasma vibrations. The cosmic ray subsystem studies energetic particles coming from deep space and from our own star. This is not leftover science. This is the only active science we have in that region. Because no replacement spacecraft is out there doing the same job. That means if Voyager 2 goes silent, a whole stream of direct information from interstellar space goes silent with it. Nothing steps in, nothing takes over. We simply stop hearing from that frontier. If hidden stories like this are why you come here, subscribe now, because this is exactly the kind of mission that shows how much of the universe remains just beyond the edge of everyday attention. And there is something else you need to remember. Voyager 2 is not sending this data across a short gap. It is sending it across a distance so extreme that your brain tries to round it off into meaninglessness. More than 21 billion kilometers. It's about 13 billion miles from Earth. The signal travels at light speed and still takes about 19 and a half hours to reach us. 19 and a half hours. So if engineers send a command now, they wait nearly a full day before the spacecraft even hears it. Then the response takes nearly another full day to come back. Every interaction happens with patience measured in light travel time. Every correction arrives late. Every mistake is expensive. And the signal itself is weak, ridiculously weak. By the time Voyager 2's transmission reaches Earth, it is only a tiny fraction of a billionth of a watt. That is not a poetic exaggeration. That is why the Deep Space Network matters so much. NASA's Deep Space Network is a set of giant radio dishes in California, Spain, and Australia. They are spread around the planet so that as Earth turns, at least one site can keep contact with distant spacecraft. These dishes are enormous. Some stretch more than 200 feet across. They catch whispers from the dark. Without them, Voyager would already be gone from us. Think about what has to happen for one piece of data from Voyager 2 to reach a scientist's screen. A spacecraft smaller than a car has to remain alive in deep space after nearly 50 years. Its power system has to keep working. Its antenna has to stay pointed precisely enough toward Earth. The signal has to cross billions of miles without becoming lost in background noise. A receiving dish on Earth has to be listening at exactly the right time. The faint transmission has to be amplified, cleaned up, decoded, and turned back into numbers. Only then can a human being begin to ask what it means. That is how fragile this conversation really is, and still it continues. Suzanne Dodd, Voyager's project manager, said the Voyagers have been deep space rock stars since launch, and the team wants to keep them that way as long as possible. That line stayed with people because it sounds light, but underneath it is a hard truth. The power is running low, the choices are painful, the mission survives because people keep inventing ways to save pieces of it. Linda Spilker, Voyager's project scientist, has been just as direct in a different way. Every day, she said, could be the last, but every day could also bring another revelation. That is the emotional shape of this mission now. Not triumph, not disaster. Suspense, quiet daily suspense stretched across billions of miles. And if that still feels abstract, here's a way to make it human. Voyager 1 is now approaching a milestone that feels almost unreal. In November 2026, it is expected to become the first human-made object one full light day from Earth. That means light itself needs 24 hours to cover the distance. Voyager 2 is behind it because of the longer route it took through the outer planets, but not by some comforting amount. It is on the same lonely road. These are the farthest active ambassadors our species has ever made, and they were built before the internet age, before modern smartphones, before the people watching this were born. That is the underdog part of the story that keeps grabbing me. We live in a time when new technology becomes old in 2 years. Screens crack, batteries fade, software vanishes, whole devices become useless after one update. And yet, this machine from 1977 is still talking to us from beyond the heliosphere. Not because it is magical, because it was built with a kind of stubborn elegance, because engineers planned carefully, because teams kept adapting, because nobody gave up when the easy phase ended, and because out there, where the environment is brutal, simplicity can become a superpower. Here's another twist most people miss. Voyager 2 is not just teaching us about deep space. It is teaching us about Earth. Not directly, but by contrast. When scientists say the heliosphere shields our planets from a large share of incoming cosmic radiation, that is not just a technical detail. It is about protection. It is about the invisible conditions that make life safer here than it would otherwise be. The sun is dangerous in many ways, but it also creates a kind of protective bubble. Beyond that bubble, the galaxy presses in harder. So when Voyager crossed the heliopause, it was not only leaving the sun's reach, it was showing us the edge of a shelter we live inside without ever seeing. That changes how you think about home. You breathe air and feel gravity and see daylight, but around all of that is another layer of safety made by our star. Invisible, vast, real. Voyager 2 went beyond it and told us what the outside feels like.